The world of AI is moving so fast, isn't it? It feels like you're always playing catch-up.
It really does. Blink and you miss something major.
Exactly. So for this deep dive, we're zoning in on some key things from the AI Daily News Digest, specifically April 25th, 2025. Trying to cut through the noise a bit.
Good idea. Yeah, the day had some interesting stuff. We saw news about AI assistants making models more efficient and something brewing in open source.
Right, so we'll cover four main areas: Perplexity Assistant, then Gemma 327B quantization, Unsloth's new quantization method, and finally that OpenAI open source model everyone's talking about.
Yep, we'll hit the highlights, give you the essential insights without getting totally lost in the weeds.
Okay, sounds good. Let's start with Perplexity Assistant then. They seem to be making some serious moves to, well, get their AI out there.
Absolutely. The big one was integrating directly with Motorola devices. And this wasn't just, sticking an app on the phone.
How so?
Well, it was about providing direct access to Perplexity's search and assistant features, like right across the whole Moto ecosystem, sort of baked in.
Integrated. And I heard there was a perk for new users.
That's right, yeah. Motorola was giving a 3-month pro subscription to Perplexity with new devices.
Nice incentive.
Definitely. Plus, the Perplexity Android app came pre-installed, and they even specifically optimized it for the Moto Razr. It feels like a very targeted partnership.
Makes sense. But it wasn't just Android getting attention, was it? iOS users got something too.
Correct. They launched an iOS voice assistant. And the interesting thing here is it wasn't just for asking questions. It could actually do things on your iPhone.
Like what sort of things?
Well, playing media, drafting emails, moving meetings around, booking rides, setting reminders, actual actions.
That sounds much more useful than just Q&A. And they were using iOS features to make it easy to access.
They talked about customizing the iPhone's action button, so you could set it to launch Perplexity voice mode directly.
So no need to even open the app first.
Exactly. Just press the button and go. They gave examples like looking up a place and then getting directions, or calling a ride, or playing podcasts, checking your schedule, sending emails via Apple Mail. All integrated.
Now, this is interesting. There was some insight into why they were doing this, particularly thinking about Google on Android.
Yes, exactly. Perplexity's leadership, Aravind Srinivas, basically acknowledged how dominant Google is. It's tough to compete.
So what's the plan?
Their strategy seems to be build an assistant they think is genuinely better, offers more than Gemini, and then partner tightly with manufacturers like Motorola to get it directly in front of users, kind of bypassing the default.
It's strategic workaround, essentially. Okay, let's switch gears. Let's get a bit more technical and talk about making these models run better. There was some analysis on Gemma 327B quantization.
Right, so quantization, it's basically about making the model smaller and faster, usually by reducing the precision of the numbers it uses without hopefully losing too much performance. And a user on our local llama did some benchmarks on Gemma 327B models that had gone through something called quantization-aware training, or QAT. They were using tools like llama.cpp and LM Studio MLX.
Got it. And I heard one of the usual ways to measure model quality wasn't quite working out.
Yeah, that's right. Perplexity, which often measures how confident a model is in predicting the next word, seemed unreliable here.
Unreliable how?
The user suspected potential overfitting from the QAT process, leading to sort of inconsistent perplexity scores between the different quantized versions. It just wasn't a clear indicator.
Okay. So if perplexity was out, what did they use to compare them?
They used a benchmark called GPQA-main. It tests reasoning and general question answering.
And what did that show?
The scores were pretty close, actually. Ranged from 0.333 for one quantized version up to 0.375 for the original unquantized model. Lower is generally better.
But you said close. Was the difference actually meaningful?
Well, that was part of the discussion. Whether those small differences were statistically significant, given the number of questions in the benchmark, about 448, I think, there's always a margin of error.
Right. So based on their test, was there a recommended quantized version?
The conclusion seemed to lean towards the Bartowski QAT Q40 GGUF version. It scored 0.352 on GPQA-main, so only a slight dip from the unquantized one.
And performance-wise? Speed.
It was actually a bit faster, maybe 1 to 2 tokens per second faster than the MLX version they tested. So it seemed like a decent balance, good compression, minimal performance hit, maybe even slightly faster generation.
Makes sense. And the community discussion dug into the testing details, too.
Oh, yeah. People brought up the importance of deterministic settings, like setting temperature to 0 and top K to 1 to make sure the results could be reproduced accurately.
Good point for benchmarking.
And someone did a deeper dive on that statistical significance, estimating the uncertainty around the GPQA-main score was roughly plus or minus 2.25% because of the dataset size. So you have to be careful drawing strong conclusions from very small score differences.
Fascinating stuff. Okay, staying on the theme of quantization, let's look at Unsloth and their dynamic V2.0 method. Sounds like another approach.
It is, yeah. Unsloth introduced this new dynamic V2.0 quantization specifically for GGUF files, those compressed model formats, and they were claiming it improves on both QAT, like we just discussed, and older techniques.
Okay, claims are one thing. Did they have results to show?
They did. They benchmarked using MMLU, specifically 5-shot MMLU, which tests broad knowledge, and also KL Divergence. That basically measures how much the quantized model's predictions drift away from the original, more accurate model's predictions. They tried to align their testing with how llama 4 and Gemma 3 results were reported for easier comparison.
And apples to apples, hopefully. So what were the improvements like?
Pretty significant, according to their report. For Gemma 3, 12B, and 27B, their dynamic 2.0 quants got accuracy very close to the original BF16 models.
BF16 being the less compressed, more accurate version.
Exactly. And they saw up to 7.5% lower KL divergence, meaning the predictions were more faithful to the original model. All this with minimal increase in file size.
So near original accuracy, better prediction consistency, and still small files. Sounds impressive. What's different about their approach?
Well, they emphasize looking at flips instances where the quantized model predicts something different than the original. They argue, based on some research, that this is a better measure of practical accuracy than just perplexity.
Interesting. Focus on actual output changes.
Right. And they mentioned using carefully curated conversational data sets to calibrate the quantization process.
And it sounds like they were also fixing things in other models, not just promoting their own tech.
That's true. They apparently found and fixed several bugs in llama 4 things related to ropey scaling, QK, norm, epsilon, head sharing, technical stuff. But they reported these fixes led to better evaluation scores for llama 4 and standard frameworks like llama.cpp and transformers.
Always good to see fixes benefiting the community.
Yeah.
But, as always, people had questions, right?
Of course. One commenter pointed out that the data Unsloth shared didn't directly compare Gemma 3 QAT versus their new dynamic 2.0 quants. It was mostly QAT versus BF16 and dynamic 2.0 versus BF16.
Ah, so not a head-to-head comparison within the Gemma family using both methods.
Exactly. Someone else asked if they plan to bring this dynamic quantization to other model types, like a Maverick version. And there was also positive feedback about them applying it to DeepSeek models, showing there's demand for these improved quantization techniques across different model providers.
Got it. Okay. Last topic for today. That OpenAI open source reasoning model. Lots of chatter about that one.
Oh yeah, definitely generated buzz. Details started emerging, again via Arlo Galama, about OpenAI planning to release an open model maybe early summer 2025.
Open in quotes.
Well, the exact license is always a key detail, but the main pitch was that it would aim to be better than current open models like Llama and Gemma, especially at reasoning tasks.
And standard interaction. Text in, text out.
Yep, standard text-based interaction. One interesting tidbit was that the reasoning abilities might be toggleable somehow.
Toggleable reasoning. What about running it? What kind of machine would you need?
The word was they were targeting high-end consumer hardware. Speculation, based on past OpenAI small models like O3 Mini and maybe O4 Mini, put the parameter count somewhere between, say, 30 billion and 70 billion.
Okay, so potentially manageable for some home users, but definitely needing a decent GPU. And the license. Any more hints on the open part?
There was some hope, maybe speculation, that it could come with a more permissive license than, say, Llama's. That would be a big deal for the open source community, allowing more freedom in how it's used and modified.
But announcements versus reality. Was there skepticism?
Absolutely. A lot of the comments were basically, great, but we've heard promises before. People pointed to past delays with other anticipated releases. The main sentiment was a strong desire for the actual model weights, not just talk, show us the model.
Fair enough. Proof is in the pudding, or the parameters, I guess. Any more hardware speculation, like VRAM needed?
Yeah, someone did a back-of-the-envelope calculation. They estimated that a quantized version, maybe at Q4 level, might need around 18 to 20 gigabytes of VRAM.
Okay, that points towards the lower end of that speculated size range, maybe 35 billion parameters.
Seems plausible, yeah. Matches how other models around that size compress. But again, all speculation until OpenAI actually releases something concrete.
So quite a day. that April 25th. Looking back, we saw Perplexity pushing hard on integration and partnerships.
Right, trying to get their assistant onto more devices, both Android and iOS.
Then deep dives into optimizing models like Gemma 3, comparing different quantization methods.
Yeah, the QAT analysis, and then Unsloth coming in with their dynamic 2.0 approach, and even fixing some Llama 4 issues.
And finally, all the anticipation and healthy skepticism around OpenAI's promised open reasoning model.
Exactly. It really captures the different facets of AI development right now. You've got the user-facing applications, the crucial work on model efficiency happening underneath, and the ongoing push-pull between closed and open development.
It definitely gives you a glimpse of the cutting edge. And thinking about all this, AI getting woven more tightly into phones, models getting powerful enough to run well on home computers, the whole open versus closed debate.
Hmm.
It makes you wonder, doesn't it?
Wonder what?
Which is about that balance.
Yeah.
As these incredibly capable models become potentially runnable on hardware you or I could own, what does that mean for innovation, for accessibility? Where does that path lead?
That's a really good question to ponder. The implications are huge. Definitely something to keep thinking about.